everyone. In today's session, we will explore the concept of validation set in machine learning. But before diving into that, it's important to understand two foundational concepts, that is, training data and testing data. Let's begin with a real world analogy. Subha is a teacher at a primary school. Today, she plans to teach her students how to solve addition problems. To do this, she prepares 100 math problems. She then divides these problems into two sets using an 80-20 ratio. 80 problems are used to teach the students how to perform addition. 20 problems are reserved to test whether the students have truly learned the concept. Importantly, the test problems are not shown during the training phase. This separation helps Subha evaluate whether the students have genuinely learned the method or simply memorizing the examples. This evaluation process mirrors what we call model evaluation in machine learning. Applying the analogy to machine learning. Now, let's translate this example into the world of machine learning. Imagine Subha is now an ML engineer, and instead of students, she is training a machine learning model to detect cancer. She uses a dataset and split in the same 80-20 ratio. Training set of 80% used to teach the model how to identify patterns related to cancer. Testing set of 20% used to evaluate the model's performance on unseen data. This evaluation helps determine whether the model is truly learning patterns or just memorizing the training data. Why memorization is a problem? You might wonder how models could memorize data. For example, suppose the training set contains 80 samples and 70 of them are labeled as cancer positive. The model might simply learn to predict positive for most inputs, even when the correct label is negative. This leads to poor generalization. To avoid this, we must ensure that the test data is completely separate from the training data. This is a key part of model evaluation. Introducing the validation set. Now, let's talk about the validation set, which plays a crucial role in model development. Instead of just splitting the data into training and testing sets 80-20, we can divide it into three parts using a 60-20-20 ratio. Training set of 60% used to train the model. Validation set of 20% used to fine tune the model and select the best configuration. Testing set of 20% used for final evaluation. The validation set helps with model selection and hyperparameter tuning, choosing the best settings that improve accuracy and performance. Limitations and the role of cross validation. While this three-way split is useful, it comes with the trade-off less data for training. With smaller training sets, the model might miss important patterns, leading to underfitting. To address this, we use technique called cross validation, which allows us to train and validate the model on multiple subsets of the data. This ensures better learning and more reliable evaluation. We will explore cross validation in more detail in upcoming sessions. Thank you for joining today's discussion. Looking forward to diving deeper into model evaluation techniques next time.